The line L1 has equation here, where q is an integer. The line L2 has this equation. The lines L1 and L2 intersect at the point P. Show that q is 4, and find the coordinates of P. Show that L1 and L2 are perpendicular. The point A lies on L1 where lambda is 1. Find AP squared. Point B lies on L2, so that the right-angled triangle APB is isosceles. Find the coordinates of the two possible positions of B. So that's the question then. Here it is here. So let's have a look at it. So I'm going to work on this question, because it's a long question, progressively as we go through it. So I'm just going to move, or try and move, this stuff down, hopefully. Oops, I'm just going to try again. I think one last try at this. Attempt. Yeah, we're okay there. Okay, so the first thing to do then is L1 and L2 intersect at P. So this is part A then. So show that this holds. Okay. Right, show that Q is 4 and find the coordinates of P where the lines intersect. So here. The lines intersect, so that would mean the x, y and z components are equal on the two lines. So 0 plus 2 lambda. 2 lambda is equal to then 8 plus 2 mu. And then we've also got minus 2 here, plus no lambdas, is equal to 3 plus 5 mu. That's number 2, I'll put there. And number 3, q minus lambda is equal to, and then it's 5 plus 4 mu, isn't it? 5 plus 4 mu, and we can label that number 3. So this one here, look at 2, we can get mu straight away. So 5 mu is equal to, so let's just move the 3 over to minus 3. Minus 2 minus 3 is minus 5. So that tells us that mu is equal to, move the 5 from times to divide, is minus 1. So there's mu. Now we've got mu, we can sub it in 1. And here 2 lambda. Oh, there's a 2 common here, here and here, isn't there? So we can just write lambda and divide by 2 all the way through. 4 plus mu. Mu is minus 1. So lambda is equal to 4 take 1 is 3. So there's lambda. And now we also want q, don't we? So with that, those thoughts in mind then, let's have a go at that. Let's move this section B down a bit to here. And then we need the third equation now gives q. So q is equal to then 5 plus 4 mu. So it's 5 plus 4 mu, which is minus 1. And then move the lambda over to be plus lambda, which is 3. 5 take 4 is 1, plus 3 is 4. So q, as was asked for, is equal to, as was stated, is equal to 4. So we've done that. The coordinates of P. P has coordinates then. Well, basically these three equations are the coordinates of P, both sides. So the first one would be 2 lambda, say. So it's 6. The second one is 3 minus 2 is the easiest one to get there. And the third one is 4 take away lambda is 4 take away 3 is 1. Let me just check that then. 5 plus 4 is 1, yeah, that's okay. So that's P. So we found out that then. So we've done part A. Show that L1 and L2 are perpendicular next. Let's have a look at that, part B. Just put that there. And now we need the dot product of both of those directional vectors in the lines, don't we? So this dot this. So it's 2, 0, minus 1 and 2, 5, 4. 2, 0, minus 1. Dot product with 2, 5, 4. We only need to write them down from above. 2 2s are 4. 0 times 5 is 0. And minus 1 times 4 is minus 4, so yes, it equals 0. So they are perpendicular, and we've verified that. So dot product is 0. So part C, A lies on L1, where lambda is 1. So A has coordinates then, let's just get those. Lambda is 1. So if we go back up here and put lambda as 1 in, I'll just put it here in rough. 0 plus 2, 2 ones are 2, plus 0 is 2. And then lambda is 1, but that's 0, so we've got minus 2. And the we've got 4. Minus 1 is 3. So that's A. So I'm going to write that down here now. 2 minus 2, 3, wasn't it? Yeah, that's it. So 2, minus 2 and 3. So there's A. Find AP squared. So P is 621. So AP squared then. So again, I'm just going to move this stuff here, if I can, out of the way, and put it below. Okay, so AP squared now then is equal to 2 to 6 is for difference of 4, so square it and you get Pythag, don't you? Minus 2 and minus 2 is 0. And then from 3 to 1 is a distance of 2, so that would be 2 squared. So what do we get? We get 20. 16 plus 4 is 20. So AP squared is 20. Now part 2. B lies on L, 2, so that the right angled triangle APB is isosceles. Find the coordinates of B. Okay, so let's have a look what we got then. We've got our two lines, and we're told they're perpendicular. So there's L1 and there's L2. P is the point of intersection, isn't it? Where the line's there. A lies on L1. And A was 2 minus 2, 3. If we can read that, we've got A there anyway. P, I'll just put the coordinates behind it. It's 6, where is P? 6 minus 2, 1. 6 minus 2 and 1, that's P. B lies on L2, so B will be here, say. So that the right angled triangle, so this triangle here, from here to here, is isosceles. So if it's isosceles, then these two sides will be the same. We know that AP squared is 20, so this side is root 20. So this side is root 20, isn't it, if it's isosceles? The only other thing to say is that there's two possible values of B, because there's also a line the other side by symmetry. So it would be over here somewhere, wouldn't it, on the sketch? I brought that back, and that would be B dashed. Same triangle this side. Okay, so let's just look at this side because the two solutions will come out from the algebra. So there's P, 6 minus 2, 1. So I'm just going to retrace my steps now with that sketch so that, because the algebra will show it anyway. So B then, what coordinates does B have? Well, it's line L2. So we know it has a parameter. I'm going to use a parameter T. So it'll be 8 plus 2T. 3 plus 5t, 8 plus 2t, 3 plus 5t, and the z component, let's just flick back up, get that one, 8 plus 2t, 3 plus 5t, and 5 plus 4t. So let's put that down, 5 plus 4t. Okay, so that distance PB then is root 20. So PB squared equals 20 gives. So the difference, 8 to 6 is 2 plus 2t difference. So it'll be that squared. Plus the 3, this to this will be 5 plus 5t. That distance squared, and 5 to 1 will be a difference of 4, so it's 4 plus 4t. That squared, as we said, is equal to 20. So now it's just a matter of working out this quadratic finding t. So we've got 4 plus 4 and 4 is 8t, plus the 4t squared when we expand that bracket, plus 25, plus 2 25s are 50t, plus 25t squared, plus 16, plus 16 and 16 is 32t, plus this squared is 16t squared equals 20. So what have we got then? T squared's 4, 29, 39, 45. Plus, now the t's 8, 58, 60, 90. And the numbers 4, 29, 29, 39, 45. Move the 20 over to minus 20. 45 minus 20 is 25. That's nice because it divides by 5. So we can divide by 5 all the way through. 9t squared plus 18t. Tap it in the calculator if you need to, and 5 there. So we've got a 5 and a 1. We know that. And now we can see it's going to be 3 and 3, isn't it? With a plus all the way through. So that tells us then t is equal to minus 1/3. And t is equal to minus 5/3. So we can get our two possible values of b. Okay, so what I'm going to do now is I'm going to take these coordinates for b here, and I'm just going to paste them here, and then we can work with those. So, what have we got then? Let's have a quick look. Just tidy up what I brought with us. And now let's have a look. So put in minus 1/3. 8 minus 2/3. 8 minus 2 divided by 3. 22 over 3. And then 3 minus 5/3. Well, that's 9/3. Minus 5/3 is 4/3. Tap it in the calculator if you need to. And then the next one, put minus 1/3 in here, is 15 minus 4/3 is 11/3. So that's the first possibility. Or B is put minus 5/3 in here. Minus 10/3. 24 minus 10 is 14/3. And then we've got 3, which is 9/3. Minus 25/3 is minus 16. As I say, tap this in the calculator if you need to. And then 15 minus 5 4s are 20 is minus 5/3. So I would double check these in the calculator because it's easy to make a mistake. So let me just run through them very quickly again. Put the minus 3rd in here. 24 minus 2 is 22. 3 minus 5, 9 minus 5 is 4. 5 minus 4, 15 minus 4 is 11. And then the next one is minus 5, minus 10/3, 20, 14. 25 minus 16, that looks okay. And then the last one, 5 is 15/3. Minus 20/3 is minus 5/3. Yep, that looks fine.